Thanks again for having me and for recognizing our efforts on this project. And, Adam, that was very nice. It is definitely a team effort. I play a part in this, and I'm really happy to be talking to you about this today. I'm going to talk about the open collaborative analysis piece of the OpenPPTGI project. I really want to leave you with, over the next few minutes, a little information about the why, although I feel that folks in this audience certainly understand that, and also a bit about the how, because there's quite a few things that kind of go into this. First, I just wanted to talk about the organization I'm a part of just briefly. I work at the Childhood Cancer Data Lab. That is a program of Alex's Lemonade Stand Foundation. We're coming up on our 4th anniversary, and we were founded with the mission of empowering pediatric cancer researchers poised for the next big discoveries with methods, data, and knowledge to reach those. So the Data Lab is made up of several teams. We have a science team, we have a design team, and an engineering team. And as Adam mentioned, I have recently taken over from the first director of the Childhood Cancer Data Lab, Dr. Casey Green. And I also just want to provide a little context for myself, say hi, nice to meet you. The two most important points I would say from this slide is I've been a practitioner of this process of analytical code review for about 5 years. And I've also run our small data science team for a few years now, which means I have experience of working with other people on the same code base to kind of reach a goal, tracking work associated with that. And I use a lot of the tools I'll briefly mention today to do things like develop material for bioinformatics training workshops, which is a slightly different goal, but a lot of the infrastructure is shared. So that is more than enough about me. Let's talk about OpenPPTGI. So the objective here is to produce a landscape paper, right? That's the end goal, that's the work product, the deliverable, if you will. And it's a landscape paper is often a data description effort. The data set OpenPPTGI is describing is the Pediatric Brain Tumor Atlas. The point of distinction for this particular project is that we're performing all of the analysis and writing the paper collaboratively in the open. So that's a little bit different than how things have been done in the past. And you need to be able to do that. There needs to be kind of some technical backbone to be able to accomplish this out in the open. And there are some key features of where OpenPPT lives, which is a place called GitHub, that allow us to conduct this project. So GitHub, if you're not familiar, is built on top of a version control system or source code management system called Git. And what Git allows you to do is basically track changes to your code and keep track of the versions of your code base. What GitHub adds on top of this is the fact that you can file issues. So you can say, here is a unit of work I would like to accomplish, or here's a discussion I would like to have. And it allows other people to comment on that issue that you filed. So that allows you to surface and track work, have discussions. In the context of this particular work, you can do things like propose an analysis. You can report a bug, because anybody who's written code knows bugs can happen from time to time. And the other thing that this allows us to do is take part in this process called code review. So code review, if you're not familiar, is a software engineering QA process where essentially one or more people read and comment on source code that they did not write, and they suggest improvements. So as I mentioned in the last slide, there are basically two parts of this. There's the analysis piece, and then you have to write the paper. So this lives in basically is segmented across two repositories, the analysis repositories where the analytical code review happens, and the analytical code and results live is called OpenPPT analysis. The manuscript side is in a repo called OpenPPTGI manuscript, which is powered by something called ManuBot. But for today, I'm going to focus on the analysis side because it is, I will say, certainly more mature than the manuscript at this point. Let's see. Okay, so now that we've talked about kind of GitHub and the how this can work together, let's talk about some of the guiding principles and assumptions that we make putting the open in OpenPPTGI. Because when we talk about open science, there are many different facets of that, including kind of making sure everyone can access your publications. For this particular project, some important points. When things are open and reproducible, it tends to make things more efficient, certainly in mine and other people's opinions. So if I'm an individual contributor, in the long term, being able to go back and find problems I've solved in the past, analysis I've done before, and reuse that code makes me go faster. The other thing is I can see what other people have done who have maybe more relevant domain expertise than myself, see what they've done in the past, how they've solved problems, reuse it. My science goes faster. On top of that, people can see what I've done, what others as part of this project have done, and hopefully first fully understand what I've done, because sometimes the methods section cannot fully capture what you've done, but they can also reuse it as well. The other thing that commenting on GitHub specifically allows you to do is, and have all of that be captured, is that sometimes it can capture what I'm going to call unseen scholarship, scholarship that doesn't make it to a manuscript sometimes. So there's a lot of scientific decision making. There are things like negative results that can make it into the repository that in other cases would be in a supplemental display item, never see the light of day or be discoverable in email threads. And it can be really, really powerful to do something that doesn't work publicly, have a discussion with someone who's duplicating your effort, and then send them a link and be like, hey, this didn't work for me. And maybe they're able to change directions in a way that is really positive for their own work and positive for all of us in the community. The other thing about having a project be open and hopefully having people self-select is that you're able to harness diverse expertise. No one individual group or contributor is going to be best suited to work with every single data modality or do every single analysis. You know, we all have, everybody who takes part has very specialized expertise in a lot of cases, and working all together, we're going to have the best product possible, hopefully. And the last piece is it allows us to report issues in real time. So for me, one of the most valuable things I think about something like a landscape paper is that you're describing data with the hopes that other people will go and use it for discoveries and things of the like, right? So in describing that data, you're increasing the value and utility, hopefully. But along the way in using it, sometimes things are uncovered, sometimes you make mistakes, and having that all happen and not have to wait months and months and months for that to come out can also be really useful. So what does this process look like? I'm about to present a very clean and linear version of real life, but hopefully that gives you an idea of what it's like. So an expert, someone who has domain expertise relevant to a particular analysis, hopefully comes along, files an issue on the analysis repository and says, here is what I would like to accomplish. Because we have this commenting functionality in issues, hopefully someone who has relevant expertise, organizers can come in and they can have a discussion about the proposed analysis. Now, this is all captured. This scholarship is captured. This conceptualization is discoverable on GitHub. The next step after you come up with something is to implement it. So that expert can go along, file a pull request, which is basically saying, I would like to add this code and these results to the code base, to the analysis project. And what can happen using GitHub is you can have a back and forth about this. Somebody who didn't write that code, but may have really relevant expertise in one area or another, can come in, look at the code, look at the results, and have a discussion, review those. And this implementation, and again, the scientific decision-making that goes into some of this is captured and discoverable. And hopefully, the ideal case is eventually this goes on into a manuscript, right? So an expert can file a pull request. Instead of code now, we're talking about basically tracking text, figures, things and the like. And then you have the same kind of mechanism where you have a back and forth. So this would maybe normally take place in like a Microsoft Word, where you send back and forth, or Google Docs. Now we've essentially just moved this onto GitHub. And I kind of like to think of this as the kind of documentation and reporting phase of the project. So this is wonderful that the idea is to capture all of this and have this be discoverable. It's also it's hard, I'll be honest. So this is, there are several kind of technical parts of this that can make it challenging. I want to highlight a couple. You need centralized access to data, and not just kind of the data that you might think of immediately. Things like tumor mutation burden that goes on and is used by multiple different analysis modules. You need to have that in a centralized location. You have to solve that problem. Code you need to check that it can be executed, and you need to check that it can be executed months and months from now when the data has changed. So we need to automatically test that using something called continuous integration. And the other thing is, if you have ever kind of emailed code to someone else and they've tried to run it and they have different versions of software on their computer and it breaks, then you can imagine where we have lots of different contributors, how that can be really challenging. So we use something called Docker to make sure things can all run in the same environment. And in some cases, folks can develop in our Docker image. So if you're thinking of setting something like this up, which I would encourage you to, I am happy to share lots of lessons that we've learned setting this up. So this was publicly announced at the end of September in 2019. At this point, we've had 550 plus pull requests merged, about 25 contributors to the analysis repo only, I will say, from 10 different institutions, over 40 analysis modules, and I checked our most recent release, and the majority of tumors have subtyping information at this point. So let's see. Well, I can't, unfortunately, it doesn't look like the photos of folks are loading, but I wanted to share one little vignette story of some interactions that kind of happened between contributors on this project, only one of which was me, only one from our core organizing team. So in March 2020, Candace, who you cannot see, but as part of this didn't load, put in a pull request, adding a figure, doing something called mutational signature analysis, and it was merged. And that was all well and good. We were like, we did it, mission accomplished. The next day, Anna, who again, you can't see, filed an issue and said, the current issue for mutational signatures is very nice. I am, however, worried that there may be problems with fitting, which is to say, this looks great. I think it's wrong. Which it was nicer than that. There was a lot more helpful context, things like that. But the gist of it was like, this looks great. I think it's wrong. And we're very grateful for that. So what happened after that is what Anna did was file a pull request, taking a different approach called de novo mutational signatures extraction. And admittedly, it can be kind of challenging to work in the context of this particular project. There are things like continuous integration with, sometimes you haven't worked with that before, and that it could be kind of tricky to get things through at times, admittedly. So Anna and I had a back and forth about altering the code in the pull request to get that in. And what we decided actually was that given different folks' bandwidth, it would be more useful for me to come in. The right course of action was basically to have me adapt Anna's code and put that in basically the context of this particular project. So what we were able to do from there is have Anna review my code, give me comments, have a conversation back and forth of that. And Anna says, wow, seeing the way kind of you've designed this here has been helpful for me. I have never done anything like this before, which is, I think, until Adam's introduction, the nicest thing anyone has said to me. And then what happened, I was gonna not be away from this analysis for a little while. So what I did was file an issue documenting the next steps for analysis. Here are some gotchas. I have this conversation I had, this back and forth with Anna that's fresh in my mind. And wrote it down, filed an issue, let it go for a few months. There's a different contributor named Stephanie who picked up that issue, extended my existing code that made it into the code base and was reviewed by Anna. And then this is ongoing, but Stephanie's current direction was inspired by a comment on issue extraction about de novo instruction. So basically there was an additional comment on Anna's original issue that has kind of inspired us based on Stephanie's result to perhaps go in a different direction. Wanted to thank the organizers. So this is a joint effort between G3B at CHOP. I want to in particular recognize Jaclyn's efforts as part of this. You can see we have many different analysis repo contributors. So these are just folks that had things make it into the code base. There are more that have commented. And obviously, a lot of the analysis happens downstream of monumental efforts by lots of folks. So with that, I will say thank you for your attention. Thank you again for having me. And take questions if we have time.
Thanks so much, Jaclyn. And I wanted to, one of the things that sometimes it's hard to capture. Like you did an awesome job capturing, the amount of dedication, communication, and collaboration that it takes to make sure you're getting something right. And I just wanted to highlight that, the outcome of getting it right is that once you get an analysis like this done, it serves on behalf of a landscape manuscript, but it also serves as a new context to interpret the next patient's data set. So essentially the next patient that comes through our door, who we sequence and analyze, suddenly has a new framing that's been vetted, looked at by a large number of people, iterated on, and can be contextualized in ways that you'll hear from Adam Craylayer today. But it's all that work that's required to be undertaken in order to get from that raw genomic data to understanding the biological setting, of the next patient that comes through our door. So I just wanted to link, your efforts to things that are already taking place on behalf of the interpretation of clinical patients as we iterate through these, highly vetted workflows.